and the next 2 lessons after this are all correlated completely to grade 12 trig. Now, grade 12 trig is actually 2 units. So 2 of the 2 really big units in grade 12 are trig, and they're not triangle trig like you're used to. They're unit circle trig like the one behind you. You guys will know how to do that by tomorrow. The good thing about it, it looks really complicated, but it's not. You'll be like, oh, this is easy. It's an easy mark if I made you draw that, trust me. On there's all those things with pies. In the middle, if you look, there's like 2 pi over 3, 3 pi over 4, 5 pi over 6. You're in grade 11, we don't make you do that. That's radian measure. You'll have to do that in grade 12, but you won't have to do that this year. You only have to do degrees, which makes life so much easier, trust me. Okay? So in grade 10, when you did trig, you did triangles. You used Pythagorean theorem where it was c squared equals a squared plus b squared, or hypotenuse squared equals side squared plus side squared, right? It doesn't matter if it's c, a, and b. And then you did SOHCAHTOA, so you did tan, sine, cos of a right-angled triangle, right? And we'll be using some of that in the trig that we're doing today and tomorrow and the next day. And then you're going to learn how to solve triangles that aren't 90 degrees as well. That's the 2 last lessons, okay? There's really only 5 big lessons in this unit. There's quite a few units in this in your textbook, but a lot of them only have like 5 lessons, right? Okay. So all of this is going to be new to you, the stuff from today, because it's not triangles. It might involve us using Pythagorean theorem and such, but actually we're going to be looking at Cartesian planes more so than a triangle, or triangles fitted onto a Cartesian plane. So the diagram in group A shows the angles in standard position. The angles in group B are not in standard position. What are the characteristics of an angle in standard position? So these 3 are in standard position, and they have little, like, this arrow goes up, and then this arrow, and then this arrow, and then this little theta. This symbol right here is a theta. That just means angle. I always say it looks kind of like a cowboy, but you can go like that if you want. You can make it long and have it like a cowboy hat if you really want to. It's just theta. It's just what the angle means. I could put it as an X. I could put it as a Y. It's just another variable, okay? So don't let it throw you off. Now, if you look at group B here, look. So in group A, it's like this, just in case you can't see it. You have 2 arrows like this and like this. You have 2 arrows like this and like this. And you have another arrow like this and like this. Okay? Group B, however, is not in standard position. I have this random angle out here. I have an angle here, and then I have an angle here. What do you notice about group A that doesn't occur in group B? The angles in standard position as opposed to the angles not. Yeah. Yeah, one of the arms is always on the positive x-axis. So that's called your initial arm. That's where it starts. Your initial arm is on the positive x-axis. Your initial arm is on the positive x-axis. And then we start from that positive x-axis and we draw the angle until we hit our terminal arm, right? So we always start, it's called the initial arm for a reason. We start at the initial arm. And go to the final arm. Remember, if you're sitting together, you need to be quiet. The final terminal arm. So we're following it around to the terminal arm, we're following it around to the terminal arm, we're following it around to the terminal arm. And where the initial, the positive x-axis meets with the terminal arm is where my theta is, right? Here, this one's drawn randomly off the side. This one, some people will say, well, I went from my initial to my final. That's the same thing, right? But my initial, this arm is not on the positive x-axis, so that's why it's not in standard position. And then this one's just randomly drawn somewhere else. Now, this angle is always rotated about 0, 0. Okay, It always is rotated about the 0, 0 on the Cartesian plane. Now we're going to do some remembering of just a couple things. So the Cartesian plane is here. It's just a graph, right? Quadrant 1, Quadrant 2, Quadrant 3, Quadrant 4, we're supposed to label them. Do you know where Quadrant 1 starts? Do you remember? Yeah, maybe? Close. Top. Yeah. Now, it starts on the top right. So we have 1 here. And then people always want to go clockwise, I think, because you're used to clocks or something. But it actually starts on the top right and goes counterclockwise. So this is 1. This is 2. This is 3. This is 4. Okay. Then we have to label the positive x-axis is 0 degrees because that's where we start initially, right? When we do standard position, we start on the positive x-axis at 0 degrees. And then we're going to label all of our axes around until we get back to 0. Now, we go counterclockwise because that's what we did on all those standard position angles. We went counterclockwise, right? So if I go from here to this arm, how many degrees have I gone? 90, because I can draw a little square in there, right? So it went 90. So to get to this arm, I'm going to go another 90, which is 180. And then I'm going to go another 90, which is 270. And then I'm going to go another 90, which is 360. How many degrees are in a circle? 360. That's why we can draw the unit circle on the Cartesian plane, because the Cartesian plane covers 360 degrees. So actually, if you look at the unit circle, if you go straight down the middles and straight down the sides, you'll see 0, 90, 180, 270, 360 drawn in that unit circle because the Cartesian plane can fit inside of it. Okay? Next page. In geometry, an angle is formed by 2 rays with a common endpoint. So when you have 2 rays, those are the arms, with a common endpoint, our endpoint that they share is always 0, 0. The starting position is called the initial arm, like I said, the positive x-axis, and the final position is called the terminal arm of an angle. If the angle of rotation is clockwise, then the angle is positive. So if we go clockwise this way, we're always going to get positive angles. You're going to go 0 to 90 to 180 to 270 to 360. However, if I go counterclockwise, I get negative angles. This would be 0, negative 90, negative 180, negative 270, negative 360, because we would just go this way. Okay? So counterclockwise, positive angles, clockwise, negative angles. So you do a sketch of a standard position angle and one non-standard position angle from what we just did. What we just learned. You could give numerous examples of both, right? Then I want you to draw an angle of 45 degrees in standard position. So very first thing I always do when I have to draw in standard position, first thing I'm going to do is make sure my phones are all away. So every single person's phone that I can see out needs to go away. Thanks. Now, secondly, what I'm going to do is I'm going to always draw out my angles on the arms, what my angles are, because that will help me. So this arm here is always 0 degrees. This one is always 90. This one is always 180, 270, 360. Why do I draw these? Because they help me figure out exactly where my angle is going to fall between, at least which arms, right? It gives me at least a shot at which quadrant they should be in. So 45 falls between which two numbers? 0 and 90. And 45 is what? In the middle. So what you can do is just draw it in the middle. And then I have my initial arm starting here. And this would be 45 degrees. Now I don't write theta, I write 45 degrees because that's what it is. Theta you write when you just know when it's just representing an angle. But when you know what the actual angle is, you write that number there instead. It's very important that you know these first 3 lessons extremely well for next year. Very important. Because these are the basis of next year's trig. So if you can come into grade 12 knowing these really well, then trig isn't as bad for people. People feel like they have a head start. Okay? So now we want to sketch the rotation angle in standard position and state the quadrant in which the angle terminates. So where do we always start when it's standard position? On the x-axis. What did I tell you you should always do first, though? What should you always do first? Label your arms. Gives you a fighting chance of getting it in the right quadrant at least. So 0, 90, 180, 270, 360. So 120 falls between what and what? Yeah, 90 and 180. Now this is the thing that I'd like to show you just in case so that you can sketch a little bit more accurately. If you look at a 90 degree, that is not drawn very well. Let's say that's 90 degrees, right? We said that 45 was halfway between. So that was a 45 degree angle, right? Keep in mind that 60 is 30 less than 90. If this is 45, then where would 60 be? Around here. And then 30 would be around here. It's important to know where to sketch your 30, 45s, and 60s because we're going to be using those lots for our reference angles later on. So how does that help us? So this is 120. You can either go from the 80, 180, or the 90 to decide how you want to draw this arm. You can go, how much is 120 more than 90? 30. So you can draw a 30. It's not going to be 40. 45's halfway, right? So we're not going to go. People will draw literally down here and say that's 120. No, it needs to be realistic. You can't just randomly throw it in that quadrant because you know it's there. I need you to draw something that looks reasonable. Okay? So I can say either it's 30 more than 90 and draw it here, or I can say it's 60 less than 180 and still draw it there, right? Either way, you pick which one you find easier. I think 30 more than 90 is better. So if I go, oh, hey, halfway is 45, well, then it's going to be less than halfway. So it's going to be about here. And then I draw my angle 120. So we have to draw it realistic. If you just throw an arm in that quadrant and say, hey, Lepp, I got it. And it's like right beside this x-axis over here. No, you don't got it. That's like 179. I'm trying to get you to draw 120. That's, no, bad. Don't do it. Okay? Now we have to say in which quadrant that terminates. So what would I do right off the bat as well if it's asking me to do that? 1, 2, 3, 4. Do I care if you use Roman numerals or real numbers? No, I do not care. Roman numerals just often are nicer to write on because you won't get them mixed up with any of the numbers around the outside or the numbers in here, because Roman numerals don't look like a number, right? They look like a Roman numeral. They're a numeral. So where does this one terminate? Terminates where the terminal arm is. Quadrant 2. So I write quadrant 2. Okay? You try the next 2. See how you do. So this one is going to be 0, 90, 180, 270, 360. And this one falls between 270 and 360. 309 is 39 more than 270, so almost halfway, right? So I'm going to draw my initial arm, and then I'm going to draw my terminal arm, almost halfway. And then I say 270 degrees. You can write the degree here or here, but you need to write it around where that little thing is. And you guys, you have to draw the arrow like I'm doing. You have to start at the initial arm and draw the arrow to the terminal arm so I know what direction you're going. Okay? Okay. And then 17 degrees is like here. Oops, quadrant 1. This one ends in quadrant 1, and I forgot to put back here, this one ends in quadrant 4. Okay? Then flip over. This one here is a multiple choice question. Okay? You circle, example 2. Which one do you think is a 70 degrees in standard position? I hope this is easy for you. If it's not, that's okay. But I hope it's easy for you. A, B, or C, what do you think? A, B, or C? B. Why? Because different than this one is that it starts at 0, 0. And my initial arm has to be on the positive x-axis. And that's the only one that follows that. Okay. Example 3 is where you're going to become friends with the person beside you, if you haven't already. If you're not, you're going to be friends with yourself, which is absolutely fine because I like myself too. So I can be friends. I'm going to be friends with myself. That's what I'm going to do. So on the back of your booklet, you are given graphs. There's little graphs. Okay? So there's one for example 3, and there's one set for example 4. They're just the Cartesian planes, okay? We're doing example 3. So using graph paper and a protractor, which I have for you, these lovely things, you're going to draw each angle in standard position. So the reason, do you guys know how to use a protractor? Like, no. Yes? Okay, good, because I was scared that was not the case. You line this line. So there's 2 lines on here. You may say you know, and then all of you will be using the wrong line, which scares me. This little cross section here, this little cross section here is where you line up for your 0, 0, right? And then this line here, not the line of the protractor at the bottom, the line that lines up with 0 degrees is the line you line up with the initial arm, right? Work your way around. Now, obviously, if it's 240, you're going to have to go like 180 and then just draw it till you get 60 more, right? Etc. So we're just going to try and draw a little bit more accurate because I want you guys to get used to your angles and be used to where you draw them. So with a partner, you're going to draw them, and I'm going to come around and check them. Okay, this is the other big concept, and this concept is huge in grade 12, huge. If you don't know the reference angles or know what a reference angle is in grade 12, about 1 unit of the 2 units, 3/4 of that unit is impossible, okay? It's a very easy concept, so it's really good that we learn it really well now so that next year it's just part of your vocabulary. Or it comes back quickly because you forget because it's been a year, but whatever, it'll still come back quick. So a reference angle is the acute angle. Acute little angle, it's a little one. Less than 90, formed between the terminal arm and the x-axis. So wherever your terminal arm is and the x-axis is... So we're going to underline terminal arm and x-axis. Extremely important. Terminal arm and x-axis. People try and do the terminal arm and y-axis all the time. So terminal arm and x-axis, very, very, very important, okay? So the reference angle is always positive and measures 0 and 90. So if you have your protractor in your hand and it's making you sidetracked because you're like, I don't know, I just keep staring at put the protractor down. Don't touch the protractor. Release the protractor, okay? Okay. So keeping in mind here, oops, it's always positive and it always measures between 0 and 90. So if you tell me the reference angle is 110, put down the protractors. If you tell me it's like 110, I'm going to be like, no, people, it's between 0 and 90. Okay. All right. So using a protractor, this is example 4, and this is in the back. Again, you have 4 Cartesian planes. Using a protractor and the Cartesian planes on the back, draw an angle of 30 degrees. Okay. And what angle does the terminal arm and the x-axis make? So we're going to go there. Not there. Okay. So you're going to draw an angle of 30 degrees. What's the very first thing we do every single time, even though you really don't want to because you feel like it's a waste of your pencil? But it is not a waste of your pencil. It is very important. Label 0, 90, 180, 270, 360. Okay. Now 30, we draw our initial arm and we draw our 30. And we put an angle in there and we say, hey, that's 30. So it's 30 degrees, but I want you to tell me what's the reference angle. So what's the reference angle? The reference angle is the angle between the terminal arm and the x-axis. It's always positive. So how far is it from the terminal arm to the x-axis? It's kind of a trick question for this one. 30. So whenever your angle is in the first quadrant, your reference angle is whatever the angle is, because wherever your terminal arm to the x-axis is the angle, right? So the reference angle for A, reference angle, that's an angle symbol, equals 30 degrees. And it's how far your terminal arm is to the x-axis. And in quadrant 1, it's always what the actual angle is. B says 150. So we're going to draw 150, but the very first thing we're going to do is label, as much as we really don't want to, because we're like, no, I don't want to do that. You're going to do it. 0, 360, 90, 180, 270. You draw 150. Okay, 150 is 30 less than 180. I'm going to draw 30 less than 180. And I'm going to draw 150. I'm going to draw my initial arm first, which I didn't do. Oops. Now you're going to tell me what is the reference angle. The reference angle is from the terminal arm to the x-axis. How many degrees are from the terminal arm to the x-axis? 30. So from, this is 150 degrees here, to 180 is 30. So my reference angle is this angle. So my reference angle equals 30 degrees. Weird, this one was 30 degrees and this one is 30 degrees as well. They can still have the same reference angle and be in different quadrants, right? It's just from your terminal arm to the x-axis. Technically, I should have drawn the arrow this way, terminal arm to the x-axis, but nonetheless, same thing. You try the next two, please. So 210. 210 falls between 180 and 270. It's 30 more than 180, so I draw it here, and I draw my initial arm here, and then I draw my angle, and I say 210. My reference angle is from the x-axis to the terminal arm. How many degrees is that? 30. Weird, we're finding a pattern, aren't we? Reference angle equals 30. Now, my only problem with giving you a pattern like this, the reason why I like doing 30 on all of them is that you can see, hey, in every quadrant there's a reference angle of 30. What's the dangerous part of that? When the test comes, you guys tell me reference angles are always 30. We did it, and there was all 4 of them were 30, and you're like, it must, forever in life, every reference angle will be 30. That is not the case. I just gave you examples that it can be in every quadrant. But like I said, the scary part, is that you might think that all reference angles forever in life are 30. That is not the case. They just are for these ones. Okay? And then 330 is here. Remember, this is why the arrow is important. The arrow is important because this is showing that this is 330. I can draw an arrow between here and it would be a negative 30-degree angle. So you have to draw this arrow and where you're going to, even though this is not drawn very well. You have to do that and say that this is 330 because there could be an angle between this initial arm and this terminal arm down here, and that's negative 330. Okay, different angle. So you have to draw that arm that goes around. And my reference angle for this one again is 30. Remember, reference angles are not always 30. I picked 30 just to prove to you that you can get a 30-degree reference angle in every quadrant, but not every reference angles can be 1, they could be 10, it could be 10.5, right? It's just the angle between the terminal arm and the x-axis. Okay, go back to example 5. Draw the angle for the degree measures listed below. Draw the angle and then tell me what the reference angle is, okay? So I want you to draw the angle and then I want you to tell me the reference angle. It's kind of really worded weird, but draw the angle and then give me the reference what the angle is. So for this one, 63, this one 23, and this one 70, because in the first quadrant, what your reference angle is, your reference angle is. Okay, flip to the next page. Okay, so how can we ask this backwards? Well, up till now, I've just given you the angle and I've asked you to give me the reference angle. Now I'm giving you the reference angle in the quadrant. I'm asking for the actual angle. So first thing we do, starts with L, rhymes with fable. Label, not stable, but yes, label. So 0, 90, 180, 270. The few seconds that this will take will save you more time in the end and get you a better answer, or probably correct. Okay, so reference angle. Reference angle is from the x-axis to the terminal arm. And my reference angle is in quadrant 2, so I know it's right here. It's in quadrant 2. It's in this one here. Now, what do? I just go from the x-axis and draw myself a terminal arm 25 degrees in quadrant 2. So what do? I go up 25 degrees here and I draw myself a terminal arm. And I know that this little angle in here is 25 degrees. But what do I actually want? The angle, this angle, the angle in standard position. How do we get it? It's just 180 degrees minus 25, right? So it's just 180 degrees minus 25. So it's 155. Okay? Now the next one says we have a reference angle of 60 in quadrant 4. Quadrant 4 is down here. But what's the first thing I'm going to do? Label. If you don't label, you guys, you have a better chance of getting stuff wrong. So just take the time and label, please. And take the time and put the degree symbol, because next year when we have radians, if you don't have a degree symbol, it's not degrees, it's radians. So we have a 60-degree reference angle. Reference angles are from the x-axis to the terminal arm. So from here to here about, we have 60 degrees. But I want the angle in standard position. So I draw my initial arm, go back to my terminal arm, and it's this angle in counterclockwise. How do I get that angle? $360 minus 60, because up to here is 360, and I'm going to take it away, that 60 away. So 360 minus 60 degrees, so it's 300. Guys. Now I have 8 degrees in quadrant 3. I have a reference angle of 8 degrees in quadrant 3. I'm going to label 0, 90, 180, 270, 360. Do you see why I told you to do this? Do you catch a girl doing this ever? Like trying to... I can't. My hand's too small. Okay, girls. See if you can do it. I can't. I think we have too little of girl hands. Or maybe we're not sweaty. I don't know. My fingers barely touch my hand. I need long fingers. See, really? Maybe that's why girls don't do it. Yeah. Really, if I go right beside my hand, I can just so hear it. Okay. Oh. Okay, 8 degrees. Pretend that that's 8. That is more than 8, but it's just so tiny. 8 degrees. So this one would be 180 plus 8, which is 188. Now we're going to go to the bottom one. 90 degrees between 3 and 4. What does that mean? 90 degrees between 3 and 4. Well, it could be 90 this way, or it could be 90 this way. Either way, it's 270. Yeah, but 90 from the x is here or here, which is 270. The actual angle is 270. Yes. Alrighty. Example 7. Okay, you guys, I want you to determine the other 3 angles between 0 and 360 that have the same reference angle as 256. So, find out the reference angle of 256 and draw that reference angle in the other 3 quadrants and tell me what the angle would be. The standard angle and standard position angle would be. So, find out your reference angle of 256 first, then draw that reference angle. Yeah, so you draw your 256. Oh, what do we do first? Label. You guys, if you get questions wrong on a test and you don't label, I'm going to put sad face with like tears and a little puddle below it. One of the classes did. I can't remember who did, though. No. Okay. 256 is here. What reference angle is that? What reference angle does 256 have? How much? 76. So then all we do is we go to each quadrant and figure out with that reference angle being 76 what the standard position angle would be. So if I drew 76 here, what would my standard position angle be? 76, because first quadrant's easy. Then if I drew 76 here, whoa, that is so not even close to 76. Oh, that sucks. Oops, put in the eraser spot, in the pen spot. Problematic. Okay, then 76 here. What's this one going to be? $104. I heard 140. I was like, no. I know, but I'm just off. Okay, and then 76 here, 284. Actually, that would be 284. So all the angles that have the same reference angle are 76. So we'll go like this. Theta equals, because that means the angle equals 76, 104, and 284. Okay? The last example we're doing tomorrow, but if you flip over to the next page, it gives you the practice assignment questions. Look at example 8 for me, please. We're going to do this one tomorrow. Oh, that was not what I meant to do. This example we're going to do tomorrow. It's determining an angle if it's reflected in the x-axis or y-axis. So in the actual homework, Any of the questions that talk about reflecting in the x-axis or y-axis, you save till tomorrow. Okay? So they're not hard by any means. Yeah. So open up your textbooks and get working. This looks like chaos is what that looks like.